Hello, this is GCSE Physics Explained, and I'm going to be telling you about distance time graphs. So the main thing is, you probably already know that speed equals distance divided by time. So Usain Bolt would run 100 meters in 10 seconds, so that means he runs a speed of 10 meters per second. If you are the higher tiered candidate, you will have to rearrange that equation. So there's the rearrangements over there. But I'm just going to focus on the distance time graph itself. Now, on the distance time graph, if you look at the gradient, it's the y-axis divided by the x-axis will always give you the gradient, y divided by x, as I'm sure your maths teachers have told you. Now in this particular case, we've got distance up the side on the y-axis and we've got time along the bottom on the x-axis. So the gradient is the speed. So that's easy to think about now, because if it's a steep slope, that means it's a fast speed, and if it's a flatter slope, that means it's a slower speed. And if it's a completely flat slope, that means it's stopped. Now, the way to remember that is if you were on a bike and you weren't allowed to pedal. If you were on a steep slope like that, you'd go very fast. And if you were on a flatter slope, you would roll slower. And obviously, if you were on a flat slope and you weren't allowed to pedal at all, well, you'd just fall off your bike and you'd stop. So, to summarise that, we say on a distance time graph, the gradient tells us the speed. And the steeper the gradient, the faster the speed. And the opposite's true. The flatter the gradient, the slower the speed, until eventually, if the line is totally flat, then the object has stopped. So, let's have a look at some different gradients. We've got a constant speed because it's a constant gradient going up steady. What that basically means is distance is going up steady as time is ticking along steadily on the bottom. Right. Oh, let's have a look at this one. Hey, you've never told us about this one. You're thinking, what on earth is happening when the gradient is getting steeper and steeper? Right. Well, what you want to do is you want to break it down, the gradient down, like this one shows. So, at first, that is quite a steep slope. So that means it's going fast. The gradient is not as steep there, so it's going slower. And the gradient has gone totally flat there, so that means it's stopped. Now if we apply that to this graph here, we can see the graph is starting off not that steep. Here it's getting a bit steeper, and here it's very steep. So what we can see is that the speed is getting faster and faster, so basically it's accelerating. Right, now you might be asked to first of all work out some speeds in your exams and then to plot those on a distance time graph. So here's a little experiment that I do with my students. I've just got this lad Callum. He walked 30 meters in 20 seconds. Chloe jogged 30 meters in 8 seconds. Carl sprinted 30 meters in 4 seconds. Liam kicked the footy 30 meters in 3 seconds. And Michael threw the tennis ball 30 meters in 2 seconds. So the first little challenge I'm setting for you is to work out the speed of all of these people. So here's an example how to do the first one. Remember, speed is distance over time. So 30 meters divided by 20 seconds, and that comes out as 1.5 meters a second. So if you want to pause the video, and you can work out the speed of all these other people. Right, I've just flicked on to the next slide. So here's the answers. Chloe was 1.5 meters per second, as I've said. Callum. Chloe was a 3.75 because she did 30 meters in 8 seconds. Carl did 7.5 meters per second, and Liam did 10 meters a second, and finally Michael, he did 15 meters a second. Right. Now if you're going to plot a distance time graph, you need to make sure that you've got distance up the side and time along the bottom, because the exam tip is whatever I say first goes up the side. So if I say a distance time graph, you know distance goes up the side and time must go along the bottom. Now make sure you've got your heading and your unit on both axis, heading and unit, otherwise you'll lose a mark. And the greatest distance we need was 30. Now the greatest time we needed was 20. So I've messed them axes up, haven't I? But you get the idea. Right, if you're not too sure about how to plot it, here's a little help. So what we had Chloe jogged 30 metres, so 30 metres, and she did that in 8 seconds. So I'll go along from the 30 and go down to the 8 and put your little cross there. And it was Callum that walked 30 metres and he did that in 20 seconds. So my graph only goes up to 17. So that should be over here somewhere. But never mind about that. Right, again, pause the video, you go and do your graph, and then come back and we'll see if you've got it right. So here is the graph. I've done the walk one already and the jog one. So the sprint, 30 metres, they did it in 4 seconds. Kick the footy, 30 metres in 3 seconds. And chuck on the tennis ball, 30 metres in 2 seconds. So what you can see is the tennis ball was the fastest because that's the steepest slope, and these were getting slower, 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 and the slowest because the slope is not as steep. And that's pretty much how to take care of business when it comes to distance time graphs. Thank you very much for now. Goodbye.